Welcome to the channel. Today our subject of discussion is accuracy calibration methods of speedometers of automobiles, motorcycles, and scooters. As far as the accuracy is concerned, accuracy calibration methods are procedures and techniques used to verify, adjust, and correct the readings of automobile, motorcycles, and scooter speedometers so that it shows the true speed as closely as possible. This is crucially this is crucial because a speedometer that shows incorrect speeds can lead to legal, safety, and performance issues. Why is calibration necessary? Because the speedometers can become inaccurate due to several factors. Number one, tire wear or changes in the tire size. Number two, incorrect gear ratios. Number three, faulty speedy sensors especially in case of digital speedometers. Number four, manufacturing tolerances. And number five, software miscalculations in digital systems. Speedometers tend to overread, that is, show a higher speed as a safety margin. But significant deviations still need correction. The types of accuracy calibration methods are: number one method is GPS comparison method. Its principle is it uses GPS speed data as a reference. Its procedure is: ride the motorcycle on a straight road or a test track. Use a GPS device like a smartphone app or a professional GPS logger. Compare the real-time GPS speed with the speedometer reading. And finally, calculate the error. If the error is consistent, adjustment can be made. The error can be calculated as error percentage is equal to speedometer speed minus GPS speed as a reference divided by GPS and multiplied by 100. The pros of this method are: it is easy, it is accessible, it is good for initial testing. The cons are: slight delays in GPS data may not be accurate under all conditions. The second method to calibrate speedometer is dynamometer testing, that is, dyno testing. Its principle is it simulates riding conditions in a controlled lab environment. The procedure is: place the motorcycle or scooter on a chassis dynamometer, run the wheel at controlled speed, compare actual wheel speed with the speedometer reading, and finally, adjust speedometer calibration settings or speed sensor readings. Its pros are: it is precise, it is repeatable, it is lab-based. Cons are: it requires expensive equipment and trained technicians. The third method which can be used is optical or radar speed gun testing. Its principle: it uses radar or laser technology to measure real speed. Procedure is: aim a calibrated speed gun at the moving motorcycle, measure the actual speed, compare it to the onboard speedometer reading. Its pros are it's good for track or road testing. It is non-invasive. Its cons are needs line of state susceptible to environment interference. Here, line of sight means that the speed measuring device, that is optical sensor or radar gun, must have a clear, unobstructed, direct path to the moving target, moving vehicle or wheel to measure speed accurately. If anything blocks, reflects, or distorts this direct path, measurement accuracy is compromised. There should be no obstacles, no reflections, no compromises in accuracy. Number 4 method is wheel circumference-based calibration. Its principle is speed is calculated from wheel rotations, altering the circumference affects readings. Its procedure is measure the actual rolling circumference of the tire with load, of course. Update the speedometer setting in digital system to reflect the new value. Alternatively, use correction gear or a sensor for analog systems. Its pros are it is accurate if circumference is measured precisely. Its cons are it is complex for analog system, needs exact tire data. Number 5 method is ECU, speedometer reprogramming. ECU means engine control unit. Its principle is adjust software parameters for accurate speed display. Its procedure is use a diagnostic tool or software interface, access speedometer or ECU, that is electronic control unit parameters, adjust value like pulse per revolution, PPR, tire circumference, or correction factors. Its pros are it's highly accurate, used in modern motorcycles. Its cons are it requires a technical expertise, manufacturer-specific tools. Here, ECU means Engine Control Unit. The ECU is the vehicle main electronic control computer. For speedometer systems, the ECU receives signals from sensor, for example, wheel speed sensor, VSS, processes the vehicle speed data, sends accurate speed information to the digital speedometer to display speed trip, to display speed, trip, odometer, etc. It ensures tamper resistance data storage, which is important for digital odometers. In simple terms, ECU is the vehicle's brain that calculates and sends speed data to the digital speedometers. Sixth method could be use of speedometer calibrators. Principle: hardware devices intercept and adjust the speed signal. Its procedure is install an aftermarket calibrator, for example, Speed Healer, input correction factor based on previous error measurements, device correct signal sent to the speedometers. Its pros are it's versatile, works with many bikes, and its cons are as hardware, not factory standard. Here, there is some more explanation. Speedo regarding Speedo Healer. It is an electronic speedometer calibration and correction device that adjusts the speed signal sent to the motorcycle or vehicle speedometer so that the display speed matches the true vehicle speed. It is not a measuring instrument like a radar or optical speed gun. Example, if the speedometer shows 110 km per hour, but the actual speed is 100 km per hour, speedometer applies a 9.09% correction. Speedo Healer is a signal conditioning device that electronically corrects speedometer readings. It does not measure vehicle speed. Speedometer accuracy and calibration chart. Based on previous discussion, here are the parameters and methods versus the different aspects and their conformity and their suitability. The major methods were radar optical speed guns, GPS speed logger, roller dyno, that is dynometer testing, vehicle circumstances-based calibration, Speedo Healer, ECU, that is speedometer reprogramming, which is an OEM method. Now, the factor is measure true speed. Yes, radar it measure true speed. GPS, yes. Roller dynamometer, yes. Here, there is no calculation. Speedo Healer, no. Here is no. Whether it needs line of sight, in case of radar signal, yes. GPS, no. Roller diameter, no. Wheel circumference, no. Speedo Healer, no. And ECU method, no. Measurement correction principle. Doppler optical, TOF. Satellite ground speed. Roller RPM. Tire rolling circumference. Pulse frequency scaling. Here software scaling factors. The accuracy of each method is as follows. Radar optical gun, its accuracy is very high. GPS, high. Roller dynamometer, very high. Wheel circumference, its accuracy is medium. Speedo Healer, its accuracy is medium to high. And finally, ECU, the accuracy is also high. Regarding the factors permanent correction, radar optical speed gun, no. GPS speed, no. Roller dynamometer chassis, no. Wheel circumference, no. Speedo Healer, no. And finally, ECU, yes. Tire load sensitivity, low. Here it is low. Roller dynamometer, low. Wheel circumference, high. Speedo Healer, medium. And ECU, low. Require reference instruments. It requires reference instruments in case of wheel circumference method, Speedo Healer, and ECU. Its legal use. Radar optical speedo gun, yes, it's applicable for legal use. GPS speed, it is a conditional. Roller dynamometer method, yes, it is applicable, it is acceptable. Wheel circumference is not acceptable. Speedo Healer is not acceptable. And ECU it is OEM. For OEM, yes, it is acceptable. The typical applications: radar and optical speed gun are typically used for certification validation. GPS method is for particularly suitable for road testing. Roller dynamometer is specially used for lab and production and new model testing. Wheel circumference method is particularly useful for workshop estimation. Speedo Healer is specially acceptable and useful applicable for aftermarket correction. ECU is for OEM productions and recalls. The legal use here mentioned is the formal regulatory approval of a vehicle system or component confirming that it meets prescribed legal standards before it can be sold or registered. In the case of context of speedometer, scooter, and any vehicle, etc., accuracy testing and calibration. The legal use refers to whether a test method or calibration approach is officially acceptable by regulatory authorities or not, particularly for vehicle type approval, market certification, road legal compliance, and a production conformity. Best practice for calibration. The best practices are baseline. To start with the baseline, always begin with identifying the error using GPS or dynamometer. Then, record data. Take multiple readings at different speeds. For example, 30 km per hour, 60 km per hour, or 100 km per hour, etc. Apply a correction. Choose a method based on your motorcycle technology level. Repeat. After adjustment, retest to confirm calibration success. This is very important. And finally, comply with the regulations. Some countries have legal limits, for example, not under reading and a maximum overreading of 10%. Coming to the summary table, the data here indicates the method of calibration, its accuracy, tools used, and its suitability. As far as GPS comparison is concerned, it is high in accuracy. It uses GPS device. It is for casual and field testing. Dynamometer testing, its accuracy is very high. Tools needed are chassis dynamometer, and it is especially useful for lab and pro testing. Regarding radar and optical speed gun, its accuracy, of course, is very high. The tools used here, as the name indicates, is speed gun. It's particularly suitable for field testing. Now coming to the wheel circumference based. Its accuracy is medium. It uses tape measure and specs, etc. It is suitable for analog and digital systems. And ECU speedometer reprogramming. Its accuracy is high. It uses diagnostic tools for calibration, and it's particularly suitable for digital and modern bikes. Finally, speedometer calibrators. Its accuracy is medium to high, and the tools needed are calibrator devices, and it is especially useful for custom setups. Now, coming to analog versus digital speedometer, a quick review. It is important distinction. Analog and digital speedometer work differently. So, the methods used to test and calibrate them also differ. Let us break down clearly. Look at the feature, how it is concerned related to analog speedometer and digital speedometer. Display. The display feature in case of analog speedometer is needle and dial. And in case of digital speedometer, the speed is displayed through digital numbers, that is through LCD or LED screen. In case of the analog speedometer, the source of signal is mechanical device, that is combination of cable from gearbox or wheel or basic electric sensor. And in case of digital speedometer, it is electronic sensor data processed by ECU. Adjustability. If we calibrate, the adjustability in case of analog speedometer is very limited, and it is through mechanical and wire gear change. In case of digital speedometer, it is software based or via ECU, that is engine control unit. Common on older or budget motorcycles, and here it is for on modern motorcycles. Calibration testing methods analog versus digital speedometers. Let us consider in a different style. Methods, analog speedometer and digital speedometer. The method discussed was GPS comparison. This method is equally suitable and applicable to analog and digital speedometers. It is universal methods for both, only test accuracy. Dynamometer testing, dynamometer, it can be applied to both analog and digital speedometer. It is lab-based, suitable for both types. Radar speed gun testing, it is also applicable to both type of speedometer, that is analog speedometer and digital speedometers. Note, external measurements works for both. Wheel circumference calibration. In case of analog speedometer, it is limited, and in case of digital speedometer, it is acceptable. Analog speedometer may require gear change. Digital uses software. ECU software or reprogramming. This is just not applicable to analog speedometer, and it can be applied to digital speedometers. Only possible in digital system. And speedometer calibrator. Yes, in case of analog, in electric analog types, and in digital speedometer, yes. Works if speed signal is electrical, not for purely mechanical types. More detailed guidance regarding best method for analog speedometer. Method GPS comparison. It is best method to identify the error. Radar gun testing. It is the best method to get actual versus indicated speed. Wheel circumference measurement. It is more useful if you can replace drive gears or sprockets. Dynamometer testing. It is ideal for professional calibration. And speedometer calibrator. It is only suitable best if your analog uses an electronic signal. Adjustments in analog speedometer is often mechanical, changing speedo drive gear ratios, replacing cables or gear mechanism, installing mechanical adjusters, which are very rare. That is how which best method is useful for analog speedometer. And which best method is used for best for digital speedometers? Let us consider GPS comparison. For it is best for easy field testing. Radar gun testing. It is good for higher accuracy. Dynamometer testing for lab level accuracy. Wheel circumference input often configurable via software or diagnostic tool. ECU accurate and factory grade calibration. Speedometer calibrators plug and play for most digital bikes. Adjustment is often via software. Accessing the ECU with OBD2 tools or manufacturer software. Setting a correction factor, for example, if it overreads by 5%. We use the term speed gun and radar gun. Let's compare both type of instruments. Speed gun uses the technology of radar or laser, where and it is its general terms. Radar gun uses only radar, which is a subcategory of speed gun. Speed gun is a handheld or tripod mounting device used to measure the speed of a moving vehicle. Radar gun is a type of speed gun that uses radio wave, that is radar, to measure speed. Speed gun is commonly used for traffic police, and a radar gun emits radio waves that bounce off a moving vehicle. Speed gun was usually Doppler radar or laser, that is LiDAR technology, whereas radar gun calculates speed from the change in frequency, that is Doppler shift. Speed gun is used to check whether a speedometer reading is accurate, especially during calibration or verification, whereas radar gun is used for speed enforcement and speedometer testing. In simple terms, a speed gun is a device that measures how fast a vehicle is moving, and a radar gun, in simple terms, is a speed gun that measures vehicle speed using radar waves. Different motorcycles use different ways of generating the speed signal. You must know how your bike speedometer gets its speed information before choosing a calibration or a testing method. With this, we conclude our discussion on today's subject of accuracy calibration of speedometer. Thank you for your patient hearing. Thank you and thank you very much.